Alrighty, folks, here we go. Here's a little test lesson. This is talking about angles and angle measure. So today, the big thing we're talking about is degrees and radians. So the first thing you need to know about is a radian is just simply a different type of unit for measuring degrees. Radians, the short story of it is, I mean, you can look it up all over. There'll be all kinds of different ways of explaining it in videos and whatnot. But the way we can look at it is we know that there's 360 degrees all the way around a circle. But you also know that if you go all the way around that circle, you have gone the circumference of the circle, which is 2 pi times r. But we're going to make that radius equal to 1, and then it just becomes 2 pi. So this is very quick and very simple. We can explain it a lot more in a lot more detail, but the basic fact is 360 degrees is equal to 2 pi radians. Therefore, 180 degrees equals pi radians. 90 degrees is half of that, or pi over 2 radians. And we can keep going. 45 degrees would be half of pi over 2, so that's pi over 4. We could also do things like 60 degrees, which, if you do the math on that one, 60 degrees is going to be 180 divided by 60 is 3. So there's 3 sections, so it's pi by 3. It would look like this. If I'm there, there's 60, there's 120. So you can see that you have 3 sections there. And the other one that you could then do is 30 degrees. So 180 divided by 30 is 6. So that's pi by 6. So that would be then like taking these into halves again. 1, 2, 3, 4. I screwed up somewhere. 5, 6. There we are. Anyway, that's a quick chat on how radians go. And that's all there as well. I want to talk a little bit about the unit circle today. We won't do much more today. If you are standing at the center of our little grid, that's you right there. Yay. You, and you are back 4,000 years, and you see an object over here that we're going to call the sun. You have no idea how far away the sun is, so the easiest thing to do back then was to give it a number of 1. Now you know from Science 9 that that's actually an astronomical unit. The mean distance from the Earth to the Sun is 1. We're just going to call it 1. So really, as the sun travels around in this direction here, you know it's a circle with a radius of 1. Okay? So from our chat earlier, we know that the sun goes that way. These are the quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, because that's the direction the sun goes. The reason the clock goes clockwise is because the first clocks were sundials, which means the shadow goes the other way. But we're going to go mainly the way the quadrants go. 1, 2, 3, 4. There we are. All right. 4,000 or 5,000 years ago, people realized that if the sun was where it is in my picture there was 2 components to it. It had a height, and it had an overness. And you could be right there at that coordinate that gives you an x and a y. So the height is the y, and the overness is your x coordinate. What that all does for us, and if through years of mistranslation, so originally in whatever language, ancient Babylonians, whatever, I don't know, height was called Gia, then it became Jib, and then through mistranslation, we got to sinus, which is Latin for harbor. And that's a horrible translation because it was supposed to be height. But the closest Latin word was sinus. We now know that as the sine. On your calculator, it's S-I-N. So we now know that that y component is the sine. Like I said earlier, there's an overness component to it. The overness component is our x, and the overness is called the companion to sine, or cosine. So there we have it. We now have anywhere on this circle, at any point, that sine can go to any point, and you can have a cosine and a sine. Now, if you think about it right now, and we put our sun right at 90 degrees, in other words, what's the height of the sun at 90 degrees? The sine of 90 degrees is also the sine of, in radians, pi over 2. Remember, our radius is 1, so how tall is that? That equals 1. Don't believe me? Punch in sine of 90 with your calculator and see what you get. Following that path, if we go over here, again, actually let's stop. That's the x-coordinate. So the x-coordinate right there is 1. What's the companion to sine at 90 degrees? What's the overness when the sun's directly over your head? Should be 0. Boom. Now if the sun was over here in position 2 at 180 degrees, which is also equal to pi radians, or what do we know there? What's the y-coordinate? What is the height? The height of the sun is 0. What's your overness if you're thinking on a coordinate axis? It's -1. So you now know the cosine of 180 degrees is equal to -1, and the sine of 180 degrees is equal to 0. We can carry on to position 3 down here. We know that's 270 degrees, which is also, well, 1 full pi plus another half, so that's pi and a half, or 3 pi over 2. What's the coordinates there? You're at no overness and 1 down, so that would make the sine of 270 equal to -1, and the cosine of 270 equal to 0. You can come all the way around here. That's 0 degrees, or 360 degrees, or 0 radians, or 2 pi radians, however you look at it. Think of your ordered pair there. So the overness is cosine. So the cosine of 360 should equal the overness, which is +1. And the sine of 360 equals the height, which is 0. So that's a real quick rundown of sine and cosine and radians all thrown into one. We're going to add one other thing here, and we're going to redraw the circle here, right here, because we still haven't figured out what tangent is. So you know from grade 9 that tangent to the circle is a point that touches at one point on the circle, on the circumference of the circle. So this is called the tangent to the circle. Okay, so let's simplify this a little bit and say that I have this angle right here that's going like that, and we have those 2 points. So I am going to call this height here the tangent. And if I want to know how tall it is, I actually have 2 triangles created here. Now I don't know what that angle is, right there, but we know that that has a radius of 1 right there. We also know that the height is the sine, and the overness is the cosine. Okay, we know that that's a right angle. We know that that's a right angle, and we know that this distance right here, that red distance, is the same as the radius of my circle. It's 1. So really what I have is I have two triangles that are similar. I have that one, that is 1 theta sine and cosine, and then I have the red pinky triangle that has tangent of 1, and I don't know how long that side is. So using our laws of similar triangles, or just triangles in general, if these two angles, theta and the right angle, are the same, then we know that that other angle is also going to be the same. We'll call that Mr. Happy Face Man, which makes these two triangles similar. One is just an enlargement of the other. Okay. So if I want to know anything about triangles that are similar, the ratios of corresponding sides are the same. So if tangent, the tan side, is whatever fraction larger it is, it's going to be sine times that ratio, cosine times that ratio to get to the corresponding side. So I know tan and sine correspond. And I know that if I went tan divided by sine, I'd get the enlargement factor. And that's going to be the same factor as if I went 1 divided by cosine. So solving this, you would want to get tan by itself. So I need to multiply both sides by sine to get rid of sine. So I have tangent equals sine over cosine. If we take that back to over here, we remembered that sine was your y-coordinate, cosine was your x-coordinate. So I now know that tangent equals sine over cosine. It also equals on our unit circle, when our radius is 1, it equals the y-coordinate over x.